Okay, so today we'll be talking about division property of exponents. Okay, and once again, like I was saying earlier, when you're looking up the quotient rule, make sure you include exponents because it will give you better explanation than if you just did the quotient rule and it accidentally gave you the calculus quotient rule, and you'll be thoroughly confused as to why the heck we're doing that. Okay, so division rule or the quotient rule is whenever you're dividing two bases with the same base, or two numbers that have the same base, you can subtract their exponents pretty easy. Okay, now there is a power rule of fractions for exponents, and that's if you raise a fraction to a power, you can just distribute that power to each number up top. So once again, we have a 1 on top and a 1 on the b on the bottom in the exponent. Okay. Ugh, that just turned in ugly real fast. And you can distribute that n to each part and get your final product of just everything raised to that power. Okay. Alright, so for some examples, 3 to the 6 divided by 3 cubed, you could write it like that. And basically that's 6 minus 3, which is just 3 to the third, which turns into 27. Yes, you do still have to simplify. Okay, now on this one, 14 over 20, it's d, they're both d, so you go 14 over 20, that becomes -6. So this becomes d to the -6. Now, this was the original reason as to why we dealt with negative exponents, was because what if the amount of exponents on the bottom is larger when we subtract? Well, when that happens, just go ahead and flip the reciprocal. So this just becomes 1 over d to the 6. Okay. Alright, now this one right here, with the actual numbers, the 5 and the 10, you can just treat this like a fraction and just go ahead and treat that as 1/2. So I'm going to go ahead and re-represent that. And you could write this a whole bunch of ways. You could have a 1 up here and a 2 down here and just leave it like that. Okay, now with the exponents, if you notice this one up top is already negative and we're minusing a positive, so this becomes m to the -11th. Okay, and with that it becomes 1 over parentheses 2m to the 11th. Okay, all right, just so you can rewrite it. Now if you remember that rule that whenever you have something with a negative exponent, you just bring it down to the denominator, that is exactly what I did. Okay. Alright, now if they all have the same bases, you can just go ahead and start subtracting exponents. So this becomes 3 to the -3rd, and then that's 4 minus -6, which becomes x to the 10th, because minusing a negative becomes positive. Okay, and then that one right there, that's just a y at the end, but it's a y to the first. So you have to remember that. A lot of people make mistakes in that, and that's how they go from full points down to some points. Okay. So that becomes y to the 3rd. All right, now if you notice, one of those is a negative exponent, and that's the 3's. So this becomes, what is that? X to the 10th on the top, y to the 3rd on the top. Let me move my screen over a little bit. There we go. And then on the bottom, you're going to have that 3 to the 3rd, which turns into 27. And remember, simplify your numbers all the way. Okay. Now on this one, I'm going to put an exponent on each one of the numbers. So I distribute the 3 to each one of those exponents. So this becomes 5 to the 3rd on top divided by 4 to the 3rd on the bottom, which turns into 125 divided by 64. Okay, 1, 2, yep, that's right. All right. Okay, now if you're raising everything to the negative exponent power, you can do this one of two ways. You can distribute the negative exponent, okay, and you have to remember to put the ones on the 12 and the 5, okay, and then you rewrite it as 12 to the -2nd, x to the -8th, okay. So that one's pretty simple. And then on the bottom you have 5 to the -2nd, and then x to the 6th. okay, because negative 2 times negative 3 is that. Okay, and then what's going to happen is you're going to move this down, this one down, and then you're going to move this one up because it's a negative exponent in the denominator. Okay, and so this becomes pretty easy. You just take time to write it out carefully. So this becomes 5 squared up top, which is just 25. And then on the bottom I have 144 because that's 12 squared. Then I have x to the 8th plus 6, and that just turns into 14. Okay? Alright? And that's how you simplify it the best you can. That's how you work with this stuff. You just move them to the right areas of the fraction. Now for scientific notation, division's pretty easy. Okay? What we do is we just straight up, we divide it. Okay? I'm going to check on my calculator. 3.6 divided by 5.8. 0.6207, and it's going to be times by 10 to the, now with the exponents, that's a 4 on top and a negative 6 on the bottom, so that's going to be 4 minus negative 6, which is to the 10th. Okay, now I still do need to move the exponent over. Now I'm moving it to the right, so that means I minus 1 from here. Okay, and so we have 6.207 times 10 to the 9th, okay, as our final answer. Okay, now if you do that on your calculator, you can obviously do that on Desmos and stuff and check it out, but I highly recommend trying it by hand first because it's just a lot easier. Now, can you do the same thing with the power of a fraction type thing? Yes, you can. Just remember to distribute the exponent to the numbers in front as well, and then do your division and just work that way across. But that's division property of exponents. I hope you guys have a wonderful day, and I'll talk to you later. Bye.